So in this video tutorial we shall continue with the solving of our algebraic processes under linear equations. This time around we are going to treat algebraic fractions. Suppose we are given an algebraic equation. Solve 3x over 4 minus 7 over 3 equals 17 over 12. Whenever you see a fractional equation like this, the first thing that you need to do is to find the LCM, that is the common lowest multiple. The lowest common multiple, that is the LCM. Here, to find the LCM is found among the denominators, that is the numbers at the bottom, numbers that are placed at the bottom of the fractions. These are the denominators. 4 is the denominator of this term. 3 is the denominator of this term, and 12 is the denominator of this term as well. To find that, we can multiply them together and then divide by each of the denominator. But there is always a simple way to find LCM in which you will always accurately get the right answer without any error. Here we have 4. To do that, just bring the table down. We have 4 here as the denominator of the first term. We have 3 as the denominator of the second term. And we have 12 as the denominator of the third term. So now, which number do we think can go into 4? Let's assume we have 2 here. 4 divided by 2 will give us 2. 3 divided by 2 will give us a remainder. So we are going to bring down 3 as it is. We are not dividing it since it will give us a remainder of 1. 12 divided by 2 will give us 6. Now let's go on. 2 can still go, right? 2. We also put down 2 here. 2 divided by 2 will give us 1. 3 divided by 2 will still give us a remainder of 1. So we are bringing down 3 as it is. We are not dividing it. 6 divided by 2 will give us 3. Now, which number do we think can go again? We are not dealing with 1. All our target is to resolve these numbers into 1. And we have resolved this one into 1 already. So we are left with this 3 and 3 here. Now 3 can go into these two numbers. 1 divided by 3 will give us a number less than 1. That is a number involving decimal. So we are bringing down 1 as it is. We are not dividing it by 3. 3 divided by 3 will give us 1. 3 divided by 3 will give us 1. So we have obtained 1, 1, and 1. What we are left with is this. The multiplication of these 3 numbers will give us our perfect LCM. That is the lowest common multiple. 2 times 2, that is 2 times 2 times 3 times 3. 2 times 2, 4. 4 times 3 is 12. So our LCM, that is the lowest common multiple, is going to be 12. This is our lowest common multiple. Now, so we now know that the LCM of this fractional equation is 12. Now multiply each term by LCM, that is 12. We are multiplying each term by the LCM 12 to remove the denominators. Now 3x divided by 4 times 12 minus 7 over 3 times 12 equals to 17 divided by 12 times 12. Now 12 divided by 4, 3x times 12 divided by 4 will give us 3, that is 4 into 4, 1. 4 in 12 will give us 3. So here we have 3 minus 3 into 3 will give 1, that is 3 divided by 3 will give us 1. 12 divided by 3 will give us 4. So here we have minus 7 times 4 equals to 12 divided by 12 will give us 1. 12 divided by 12 will also give us 1. 1 times 17 will give us 17. Now 3x times 3. If you have 3x into 3 places, when you add them up, what we will get is 9x. So 3x times 3 is 9x minus 7 times 4. 7 times 2 is 14. 7 times 4 will be 28. So we have 28 here equals to 17. Now we are to collect the like term. Collecting the like term, we have only one term with variable x here. Therefore, we'll put down the term 9x equals to 17. Then we are now transferring this minus 28 across the equal sign to the other side of the equation. To do that, the negative sign in front of 28 will be changed to positive, and hence we have plus 28. 9x now will give 17 plus 28. 38 will surely give us 45. Will give us 45, and divide both sides by 9, that is the coefficient of x. From our previous lecture, if you remember, we have the coefficient of a particular variable as the number before that variable. So since we are looking for x, we are going to divide both sides by 9. 9x divided by 9 equals to 45 divided by 9. Meaning both sides of the equation has been divided by 9. 9 divided by 9 will give 1. 1 times x is x. So 9 has cancelled 9. X, we are left with x, which is equals to 45 divided by 9. And our final answer is yes, when we divide 5 by 9, we'll have 9, of course. We have 9. So our final answer is going to be 9. Yes, this is it. So let's take another more complex example. Assume we are given this equation as equation 2. Solve 2x plus 5 all over x equals to 2x all over x minus 3. In this situation, we have only two terms in this equation. One term, that is, this is one term in one side of the equation and another term in the other side of the equation. So the best thing for us to do here is to just cross multiply. We are applying cross multiplication in this type of situation. Now it's a solution. I have 2x plus 5 over x equals to 2x over x minus 3. Now when we apply cross multiplication, we open the bracket for this first numerator, which is 2x plus 5, bracket close. Then considering this, we open another bracket times x minus 3. Remember, we said brackets represent multiplication. So instead of putting multiplication, since we have more than a term for both the numerator here and the denominator here, we are using brackets to include all the terms in the numerator and denominator as well. Equals to, now we have our 2x times x. Now we are left to open the brackets. Now to open these brackets, we are multiplying each of these terms by each of the term in the second bracket. 2x times x will give us 2x times x is x square. The same 2x again times minus 3. Remember, we say plus times minus is minus. 2x times 3. 2 times 3 will give you 6, and we'll include our x. That is 2x into 3 places. There will be 6x. Of course. Now move to plus 5. Plus 5 times x will give us plus 5x. Plus 5 times minus 3. Remember, we said plus times minus will give minus. 5 times 3 will now give you 15. Now moving to the other side, we have treated the two terms in this bracket. So our bracket has been opened completely. 2x times x will give 2x square. Now collecting the like terms, that is the terms with x on one side and the terms without x on the other side. To do that, we now have our 2x here square, 2x square. Assume we transferred this value to this point. When we transfer this to this point, it is a positive term, that is plus 2x square. When we move it here, it will change to minus 2x square. Then our minus 6x is here, so we are putting it down. Minus 6x plus 5x, and we have 15 without any variable. So this minus 15, since it has no x, it has to be transferred to the other part of the equation. When we do that, minus 15 moves across That is, it crosses over the equal sign, and therefore it will change to 15, not minus again. The minus sign will be changed to plus. So we have 15 here. Now 2x square minus 2x square, surely it will be 0. So 2x square goes with 2x square. It cancels each other. Minus 6x, you borrowed 6x plus 5x and you returned 5x. You are left with only 1x. So it means you are owing 1x, which means we have minus 1x, but we don't indicate 1. Whenever we have a variable, a single variable whenever we have a single variable like this, as in we don't indicate 1 in front of that variable. We only write down the variable itself. So it's minus x equals to 15. Now divide both sides by dividing both sides by minus 1. That is minus 1 in front of x, since we are looking for x. Minus x divided by minus 1 equals 15 divided by minus 1. Now remember our arithmetic operators rules, where we said minus divided by minus is equal to plus. So here minus divided by minus will give plus, so they will automatically cancel out each other. X divided by 1 is x, equals to, here is positive and here is negative. We also stated in the rules of arithmetic operators that plus divided by minus is equal to minus. We say once the terms are not the same, they will give minus as the result. But once the signs are the same, once the operators are the same, the result will be positive. So we have plus and minus, so the result will be negative. 15 divided by 1 will give us 15. Plus over minus gives minus. 15 divided by 1 gives us 15. So we are going to stop here for now, and we shall continue in the next video. Thanks for watching. Gradually we shall move until we enter the most complex part of mathematical expressions, including further mathematics and A-level mathematics. This is how we'll go on gradually until we achieve our aim, and you will also be happy because you are going to acquire a lot of knowledge that will be useful in all aspects of life. Thanks.